Good afternoon, all the delegates, the guests here, and my students. Uh, Let me first thank the organizing committee for giving me the opportunity to make a presentation on this important topic in this August gathering. Of course, most of you will agree with me that production of ethanol in our sugar mills today is a very important aspect. It is like our bread and butter, and that has helped us in last few years to survive financially in spite of producing surplus sugar cane. So before I start, I would like to inform Mr. Uday Patil and Dr. Gore. You asked few questions yesterday. Probably you can find answers to your question in this presentation. This is the brief highlights of the ethanol blending program. I will not go into the details, but unfortunately, in this year, the sugar production in the country has reduced and it is going to be about 31 million metric ton after diversion of about 1.7 million metric ton of sugar for ethanol production. In the last year, after achieving the blending of 12%, the government of India was able to save almost foreign currency to the tune of almost rupees 24,300 crores. And in last 10 years, the oil companies have paid to the sugar mills for the purchase of ethanol to almost rupees 1,15,000 crore rupees, and this has helped also to reduce the CO2 emission to the tune of almost 42.6 million metric ton. I would like to bring to your attention the sugar balance, which is very important aspect. You can see in the table of sugar balance that in the last 2 years the government allow export of sugar, and that's why our surplus stocks were in a controlled manner. But as probably you know that this year the government is not allowing the export of sugar, and they have restricted the diversion of sugar to ethanol of 1.7 million metric ton. And even if we consider 31 million metric ton as the net sugar production and a consumption of as high as 27.5 million metric ton, we will still be having 9.8 million metric ton as a surplus sugar available with us. And if you compare this with last few years of surplus sugar, this is going to be quite high amount. I don't know why government is so panic about the sugar stocks, and I feel that government can still consider allowing us to go for higher diversion of sugar for ethanol production. Yesterday, the Honorable Minister Nitin Gadkari mentioned about the availability of the grains in the country, and I have tried to put a ethanol potential in this graph, and you can see that if the export is not allowed, right now the export of rice and even corn is not allowed, and if the export is not allowed, we have a potential of producing almost 12 to 13 billion liters of ethanol from surplus rice, and about 1 billion liters of ethanol from the corn. So the desired quantity of grain ethanol also can be produced from the surplus rice, corn, and also wheat in our country. I will not go into the detail of progress of ethanol blending program in our country. Mr. Ramakrishna has already covered this. It was very good going for last few years, but in the August 2023, government gave us a shock. They banned the FCI rice for the use of ethanol production, and again at the starting of December, they stopped they restricted the diversion of sugar to ethanol production to 1.7 million metric ton. This has put us in a real big problem. Our have invested a lot of money in building their capacities, and really right now we don't know whether we will be able to achieve, we will be able to survive financially also. Uh, Mr. Ramakrishna mentioned that 15% blending may be achieved this year, but we are very doubtful with the restricted diversion of sugar. This may not be possible. Coming to the pricing of ethanol, this is unique policy, probably once only in the India that they have given differential pricing of ethanol based on the raw material used. But government was very good. There was a very good support, and you see that every year they were increasing the prices of ethanol. But in this year 23-24, they have not increased the prices of ethanol. You can see that for C molasses and for maize ethanol, they have increased the price. It is not the price increase, it is actually incentive. So this incentive may be taken back again in next few years. So we have to be very careful about this. But we are expecting that the prices will be revised in next few months. That's what the Honorable Minister said, that wait up to April and then we'll see what is going to happen. Coming to the use of BAV molasses for ethanol production, of course BAV molasses has been a very good clean substrate as compared to our conventional C molasses. We have used it very efficiently. We were able to achieve 12 to 13% of alcohol concentration. There is absolutely no problem. We were also able to recycle spent wash to the tune of around 10 to 20%, and that's why we were able to reduce our spent wash generation also. But the main problem today, Atulji, is the stock of BAV molasses. In our sugar mills, we have a lot of stock. Yesterday I was speaking to someone. He has 50,000 tons of BAV molasses stock. At today's cost, it will be 70 crore rupees. They don't know what to do. They cannot make ENA from it, and they cannot sell it also as C molasses, because otherwise they cannot take care of their loss in recovery also. So this is a big problem, and we will have to sort out this issue. Lot of sugar mills have already written to the DFPD, and we wait for their I will skip this slide, but coming to the challenges with the syrup, of course we are not familiar with syrup fermentation. In the initial phase, we faced a lot of problem. Syrup is not as good as C molasses or BAV molasses. There were a lot of problems. And particularly in Indian context, we follow the double sulfitation method, and therefore we have a lot of sulfides also. There is no buffering capacity, and we have faced a lot of problems. But slowly we have recovered from this. For the sulfide issue, we were required to increase our fermenter capacity, increase the retention time to around 50 hours, and try to minimize the sulfide content in the syrup. Of course, some of our distilleries have shifted to desiccation. With desiccation, the problem can be resolved in a good extent. We have been able to achieve 13% alcohol concentration, and that is helped us to reduce our spent wash generation also. With syrup, we are now using active dry yeast very efficiently. We have to maintain proper yeast count and transfer at least 15% of the free fermenter volume to the fermenter. The feeding cycle is one of the most important critical factor, and it has to be properly optimized. So we get residual sugar as low as less than 0.5%, and with syrup we have been able to recycle the spent wash to almost 40 to 50%, and that has helped us to reduce the spent wash generation. Coming to the issue of sulfide inhibition, as I told you, one of the solution is to go for defecation, and some of our sugar mills have already done this. They have set up a parallel defecation evaporation system, but in this case again our capex is increasing. But in the last few years we have also switched over to diluting the sulfited syrup with either raw mixed juice or clarified mixed juice or even secondary juice, and that has helped us to reduce the problem of sulfite inhibition to a certain extent. However, we are facing a problem of low pH in the fermented wash because the syrup doesn't have the buffering capacity, and the resultant rectified spirit is also very acidic, and therefore we have faced a lot of corrosion problems in our reboilers, PHEs and piping, and we were required to switch over in the MOC from SS304 to SS316. Coming to the challenges and opportunities in grain ethanol production, of course today the government is promoting corn. They want the distilleries to switch over from rice to corn. But the most important factor probably is going to be the quality and the price of the grains, at which the landing price and the quality also. I have seen in north the corn which is available is very bad quality, infested, and therefore it also affects the quality of DDGS. And in grain ethanol also, the fuel which is purchased from outside, it is also very important key factor in the profitability. So we have to control the price of the fuel which is available, and therefore the multi-grain feed systems are now coming up. So we can put either rice or maize or even wheat also, and there are high alcohol tolerant active dry yeast which are available, and we have achieved 14 to 15% alcohol concentration, and in future probably genetically modified yeast will be also made available, and with this one can go to up to 18% alcohol concentration. There are new generation of enzymes are also available, and with these enzymes probably we can reduce our energy consumption, and with new modern kind of grain alcohol plant we have to go for a lot of heat integration, so we can bypass the jet cooker, we can go for integrated evaporation, or we can use the dryer vapors to run the evaporation system, and even multi MVR systems are also being considered, and vapor phase ethanol production. So with this kind of approach, people are now talking about coming down to 2.8 kg per liter of ethanol production. Of course, with grain ethanol, there are opportunities to recover a lot of byproducts, particularly the food grade CO2. I will talk about the corn oil and protein from rice also. And therefore there are dual feed systems which are now being considered, and even with the molasses based distillery, people are now thinking about going for integration with corn wet milling systems, where apart from ethanol and DDGS you can produce a lot of other products like the oil, de-oiled cake, gluten, dextrins and starch also. So these systems are also being considered in the distillery proposals. This is the multi-feed system, a typical multi-feed system which we are proposing. Here you can see the fermentation, distillation, the evaporation system, the condensate polishing unit. They can be common, but the preparations are required for grain. You will require separate preparation. For syrup and molasses you will require, and on the downstream side again you will require dryer for DDGS and either a dryer, spent wash dryer, or a incineration boiler for the molasses or syrup system. So this is one case study. We are working for 200 KLPD distillery proposal, and here you can see we are proposing two parallel 100 KLPD plant which will run on syrup at 200 KLPD capacity during the season, subject to government allowing us to use syrup. And in the off season, if the BAV molasses is available, it will run on BAV molasses at 100 KLPD capacity, and it will run on grain on 100 KLPD capacity. If BAV molasses is not available, then the distillery will run at 100 KLPD capacity only on the grain. So this basic concept in this this configuration is that the distillery capacity is decided based on the capacity of the sugar mill and the availability of the own raw material, plus the most important part is the availability of the fuel or the bagasse from the sugar mill to run it for 300 days. Coming to the byproducts from the grain-based distilleries, you can see that this is the first plant we established in Maharashtra. This is for the recovery of corn oil from maize, and this is called as front-end oil recovery. And you can see that before fermentation we degerminate or take out the germ, and then of course there is a refinery, and this refinery can produce good quality edible corn oil, and we are already selling this corn oil. So this is the probably first corn oil plant installed in a dry milling plant. Of course, there is a back-end recovery also possible in some of the US plant. This is being done, and what our friend Mr. Fernando explained, that one can go for the biodiesel production with the distillers corn oil production. There is also possibility to recover protein from rice. So this is one example that from rice DDGS one can recover protein. I will not go into the details of this, but again in this also there is a front end protein recovery also possible. I know one plant, one grain based distillery is now setting up a plant of a front end protein recovery. It is going to be a very high value product, and it can improve the profitability of the distillery. Coming to the challenges which we faced with the syrup is when we use the syrup spent wash, we get less biogas. Even the methane content of the biogas was reduced. We faced severe problems in the scaling in the evaporation systems. The quantity of the effluent generated was also very less, and with the syrup spent wash we had effluent which had very high fixed carbon and chlorine content, and therefore we had a lot of problem in treating this spent wash. Of course, we feel that the profitability will vary depending on the downstream effluent treatment system, and therefore today, apart from incineration, we are also proposing dryers, and now also there are potash recovery systems which are coming up. With syrup spent wash, our spent wash quantity is reduced as compared to the spent wash which is produced with CAV molasses, and that's why we faced a lot of problems in the incineration boilers. But with C molasses and BAV molasses spent wash, our incineration boilers have worked properly. I have been advocating it. We have gone for differential pricing of ethanol, and we are using different kinds of raw material to produce ethanol. But we may have to also go for allowing us to go for some new effluent treatment systems. So with syrup, if the spent wash generation is very less, probably we can go for direct composting in the season, and that we have tried to represent in many forums, but at present it is not allowed. We have to go either for incineration or drying of the spent wash from the syrup. With energy and for water conservation, already in some of the presentation this has been covered. We can go for air-cooled condenser where the water consumption can be reduced. There is no requirement of water treatment. There will be no effluent generation also, and the operation and maintenance cost is going to be less. With the new restrictions coming on the fresh water consumption, probably many of our distilleries will have to go for this air-cooled kind of condensers in the coming years. Of course, there will be more capital requirement. It will require higher electrical load. So these are the systems which are already getting installed in our distilleries. We can go for MVR based evaporation and distillation systems also. MVR based evaporation system are already installed, but now people are also talking about the MVR based distillation, where you can reduce your steam consumption from 1.8 kg to almost 0.5 kg per liter of ethanol production. So that is also possible. This is one more case study where we are working for a dedicated juice to ethanol plant, and here we can use the vapors from the juice evaporation to run the analyzer column. We can also go for the rectifier working under the MVR, and we can go for multiple MVR also for the spent wash evaporation. So this kind of system will reduce your energy and water consumption in future. VSI has worked on the extraction of potash from the incineration boiler ash. We already have one pilot plant which is running in VSI campus, and here you can see that we can recover potash in different forms depending on what is your requirement. We can produce either solid K2SO4, solid MOP, or liquid products also, and here our potash recovery is more than 94 to 95%. Coming to the last slide before conclusion, this is one more technology which is now available, and it is approved by the MOEF and CPCB, and it is for the recovery of potash and depotash vinasse from the molasses, and it is a zero liquid discharge system. It is installed in one of the distillery in Maharashtra, 60 KLPD distillery. So here you can see that from a 60 KLPD operation, you can recover almost 45 tons per day of depotash vinasse, which can go as animal feed, and it fetches a very good price. In this case, the FCO grade potash recovery is around 3.3 ton per day, but you can further purify this FCO grade potash into K2SO4 also if required, and you can get higher price. So finally, coming to the conclusion, with this background, I can say that considering the sugar balance in the country, higher diversion of sugar of about 4 million metric ton is still possible, as government has banned the export of sugar, and still 2 months are remaining, so government can consider this very seriously and can allow us to divert more sugar because BAV molasses and syrup stocks are already there with our distilleries. So in future, whenever there will be surplus sugarcane available, it will be definitely possible to divert substantial quantity of sugar through ethanol production from syrup and BAV molasses. And this is the probably answer to the question which was raised yesterday. Multi-feed distillery concept is now emerging as an important option. We can use syrup in the season, BAV molasses, or grain we can use in the off season. I know few distilleries are now this year will be crushing sweet sorghum also on trial basis, and of course sugar beet also is being proposed for extra after season operation of the distillery. For higher distillery capacities, multi-feed mode with own fuel and appropriate steam balance will be required. Profitability will vary depending on the downstream effluent treatment system. Incineration route is not really suitable when syrup is used, and incineration is a very costly affair today, and there are a lot of corrosion problems. As far as sugar mills are concerned, we get a lot of other indirect benefits when we divert BAV molasses or syrup, that is increase in crushing capacity and export of power, higher export of power, reduction in steam consumption and saving of bagasse, saving in handling and bagging charges of sugar, the amount of sugar which is diverted, We need not go for the bagging of that sugar. And of course, the most important is the reduction in interest burden of the sugar stocks. The emerging technologies such as high alcohol tolerant active dry yeast, high gravity fermentation, the advanced enzymes, air cooled condensers, MVR based evaporation and distillation, even the RO systems which are again now being proposed for reduction of the spent wash generation, and heat integration approach, they will all these factors are going to be key factor in reducing the cost of production in future. The recovery of potash, the recovery of depotash vinasse, producing compressed biogas, producing corn oil, producing biodiesel also in future, which can be combined with the distillery operation, and producing protein from rice will provide additional benefits, and technologies are available and some of the technologies are under development. However, it is most essential that Government of India is required to devise a long-term sustainable policy for boosting the ethanol production in the country, instead of flip-flop kind of policy which puts our sugar mill in a big problem. With all these emerging trends, technologically we have seen in last 2 days that there are going to be exciting challenges and opportunities in future. So thank you very much for your patient hearing.